Greetings to all learners doing technical mathematics, specifically in grade 12. But remember, I said grade 10 and grade 11 can always watch. Now, this lesson specifically will benefit grade 11 learners mostly. So grade 10 learners, even if you don't watch this one or listen to this one, the first one where we talked about right-angled triangles was actually talking to you as well. Now this one is taking it a step further in doing non-right angled triangles and looking at what is it that we have to do with non-right angled triangles. Yes, of course, this is a technical mathematics lesson for grade 12 learners and is presented by Mr. Njomeni. We are continuing with our trigonometry, doing sine rule, cosine rule, and area rule. In a nutshell, we are looking at how do we deal with non-right angled triangles in trigonometry. Right, we'll just recap a bit so that we remind each other. In our previous lesson, which was lesson number 1 under trigonometry, we talked about two main types of triangles, and then we looked at a right-angled triangle. We looked at right-angled triangle as well as non-right angled triangle. But in details, we looked at right-angled triangles, where we said a right-angled triangle will have one of the angles being 90 degrees, one of the angles being 90 degrees, and we said the side opposite to that 90 degrees is basically called the hypotenuse of that right-angled triangle. And then we looked at non-right-angled triangle. I just introduced them, and then I said, remember that a non-right angled triangle is a triangle where there is no angle which is 90 degrees. This angle is not 90, that is not 90, that is not 90, this angle is not 90, that is not 90, and that is not 90. So you will see that sign that a triangle is a right angled triangle, or you will be told that that angle is 90 degrees. Then the triangle becomes a right angled triangle. Right. Then we said, what is it that we do, therefore, when we are confronted or when we come across right-angled triangle? What must we think of? And then we said we need to think about Pythagoras theorem. And then we also need to think about definitions of trigonometric ratios. Remember, I also said, please keep in mind your Euclidean geometry, especially about angles. Sum of angles of a triangle add up to 180 degrees. Keep in mind that one. Right? Then I said we talk about non-right angled triangles, where now I said these three are going to apply now: sine rule, cosine rule, as well as area rule. Right? So today I want us to look at how the rules above are written and how do we work with these rules to solve now triangles using these rules in a non-right angled triangle. Right, so we are going to start with the first one, which is the sine rule. We are going to start with the first one, which is the sine rule. And I'm just going to use triangle ABC, right? Triangle ABC, simply because in the formula sheet, you are also given the formula in terms of A, B, and C, right? So please take note of this. In any triangle, small letter A is the side opposite angle A, which is denoted by a capital letter. And so small letter A is always opposite to the angle A. Small letter B, being the side, is always opposite to the angle B. And small letter C, which is the side, is opposite to angle C. So C is the angle. So in short, small letters are sides, capital letters are angles in this case. So please make sure that you understand that, because even your formulae are given like that. Right? So if you've got triangle ABC, there is our triangle ABC. There is our triangle ABC. You will notice something now that, okay, so if we're having triangle ABC, if that is capital letter A, then opposite to capital letter A, opposite to capital letter A will be small letter A, opposite. So capital letter B, opposite small letter, capital letter B will be small letter B. Capital letter C is there, opposite to capital letter C is a small letter c. So small letters represent sides, capital letters represent angles. Please take note of that. It is very important. This is going to apply in sine rule, in area rule, as well as in cosine rule. So in other words, it's going to be the application or the norm or the acceptable way of dealing with triangles, so that we make our lives easier. It's not compulsory, however, to write small letters when you are solving problems, as long as you know which side are you looking for, which angle are you looking for, which side is given, which angle is given, and then how do you work with each of those. All right. So basically, if you talk about the sine rule, you can just summarize it and say, in the sine rule will work as follows. It will be the length of any of the side divided by sine of the angle opposite to that side. Length of any side divided by the sine of that angle opposite that side you are talking about. It makes now us to write it as follows and say small letter a, that is the length or the side, the length of the side, it will be divided by sine of an angle opposite to that small letter a, which is sine capital letter A. Small letter b will be equal to, this thing will be equal to small letter b divided by sine capital letter B. So it is basically small letter a divided by sine capital letter A is equal to small letter b divided by sine capital letter B is equal to sine c divided by sine is equal to c divided by sine capital letter C. Let me repeat. Small letter a divided by sine capital letter A is equal to small letter b divided by sine capital letter B is equal to small letter c divided by sine capital letter C. So basically, it is just the length of any side divided by sine of that angle, of that angle which is opposite to that side that you started with, which is equal to the length of any other side divided by sine of the angle opposite that side. So it's always the side divided by sine of an angle opposite that side is equal to other side divided by sine of an angle opposite to that particular side. Remember, this is mathematics now, so if you started with sides, you can also start with angles and say it is sine of an angle divided by sine by the side opposite to that angle. Sine of an angle divided by the side opposite to that angle that we talked about is equal to sine of another angle divided by the side opposite to that angle that we talked about is equal to sine c, in this case, divided by small letter c. So it's basically sine capital letter A divided by small letter a is equal to sine capital letter B divided by small letter b is equal to sine c capital letter C divided by small letter c, which can be rewritten as the way I said is written in the beginning. Small letter a over sine capital letter A is equal to small letter b over sine capital B is equal to small letter c over sine capital letter C. That's basically how you write your sine rule. It is as simple as that, right? Now, I want us now to move on and talk about still a sine rule again. The big question is always, when do you use sine rule? When do you use sine rule? How will you see that in this problem I must use sine rule? In other words, in order for me to solve this problem, sine rule will be applicable. So the sine rule can be used, when the following information about a triangle is given. If you are given two sides and an angle opposite to one of the two sides. Now, this is very important. If you are given two sides, you must then check, is there an angle opposite to one of the two given sides? If the answer is yes, then sine rule will be applicable. Two sides are given, then when you check one of the angles the angle which is given is opposite to one of the sides that was given, then you use a sine rule. or if you are given one side and any two angles. The reason why I'm saying any two angles, it is simply because if you are given two angles in a triangle, you are given the third side, or you know the third side. Let's say this one is 50 degrees. If that angle is 50 degrees, and let's say that one is, for argument's sake, let's say 55 degrees. 55 degrees. If it is 55 degrees, then it means you are given only two angles, but you are not given two angles as a technical mathematics or mathematics learner. You are also given that side, or you know that angle, because you will definitely take a calculator and press your calculator. You'll just say 180 degrees minus 50 minus 55, and you will get your answer as 75 degrees. You'll get your answer as 75 degrees. So basically, if you are given two angles in any triangle, then you know the third angle. So in short, you use the sine rule when you are given two sides and an angle opposite to one of the given sides, or when you are given one side and any two angles, because you can always find the third one. So once again, you definitely use that formula, any of those. Of course, you just use two portions of it. That is, you don't use all the three of them. You use two, depending on what is it that is given in that particular problem. Right. I want us to do an example right straight away. I want us to do an example so that we can be able to see really how is this sine rule going to be used. Now, let's go to an example and say solve the following triangle. Example number 1, solve the following triangle. Remember, when a question says to you solve the triangle or solve a triangle, it simply means that find all the unknown sides and angles. Remember, a triangle has three sides and has three angles. So you'll be given it's either two angles and one side, or two sides and one angle, or three sides, and so on. So remember to keep that one in mind, that when you are solving a triangle, you are actually finding or determining the sides that are not given using the ones that are given. Now, in this case, you are given triangle ABC, then you are given that angle is 31 degrees, and that one is 72 degrees. Obviously, the moment you are given these two, then it means you know the third one. It means you know the third one, right? Remember what we said earlier. Remember what we said earlier, that if you are given two angles, then you can always find the third angle of that particular triangle. Right. So the first example says solve the following triangle. Once it says solve the following triangle, then you just find the unknown sides and angles, depending on which one is easier to find first. In this case, I'm already indicating that you are given this angle, you are given that angle. It means it will be easy to find the third one. So in order for you to find the third one, you just say 180 degrees minus this, what was given, and minus that, which was also given. Then you will get the answer. You simply press your calculator. There it is there. Angle C, the angle that we are not given, is equal to 180 degrees minus 31 minus 72. So it's just saying minus the sum of the ones that are given, which is the same as minus 31 and minus 72 degrees. And the correct answer will be 77 degrees. The correct answer will be 77 degrees. All right. So you have found that this one is 77 degrees. This one is 77 degrees, right? Then now you go to calculate now the length of C, which is the side C, which is this side. Now, when you're finding the length of this side, which is side C, what you do is you are going to use a sine rule. Why are you going to use sine rule? It's because you want to calculate this side and the angle opposite it. You know it. The angle opposite this side, you know it. It is now 77 degrees. So, and also when you look at the other two angles, you look at 72 degrees, you don't know that side. You look at 31 degrees, you know that side. So it's easy to use the sine rule here. So you'll therefore say small letter c over capital letter C. Small letter c over sine capital letter C. is equal to small letter a over sine capital letter A. Then there are many ways of moving from here. Once you choose a rule, you can either substitute, which is what is well known or is being emphasized. But for this one, for these few examples, I've decided to use the one where I first make what I want the subject of the formula. So I'm making C the subject of the formula, which means I don't want this sine C. I just cross multiply it, or I just multiply both sides by sine C. Multiply both sides by sine C. I'm trying to use your language as well. And multiply both sides by sine C. So it's going to be small letter c is equal to a sine A, which was there, multiplied by sine C. Then the next step is substitution here. Of course, I said you can start by substituting, which is what is usually emphasized, and then later manipulate or make your unknown the subject of the formula. So the answer will be sine 77 degrees multiplied by 4 over sine 31, because angle C is 77. So you can start with 4 over sine 31 multiplied by sine 77 degrees, or you start with sine 77 degrees multiplied by that. Now remember that in mathematics, 2 times 3 is the same as 3 times 2. And then you just press your calculator, and then you get your approximate value for angle C, right? And then to continue with that, now we don't know the small letter b. To find small letter b, once again we use sine rule. We use sine rule because we're finding small letter b when we know the angle opposite it. So it's going to be small letter b over sine capital B is equal to small letter a over sine capital letter A over sine capital letter A. Small letter b over sine capital letter B is equal to small letter a over sine capital letter A. And then we make b the subject of the formula here, so that sine b goes there and multiplies that side. So as you can see, what happened there is a sine b over sine A. Then you substitute, and then you press your calculator, so you just correct your answer to 1 decimal digit if you were asked to correct to 1 decimal digit, or 2 decimal digits if you are asked to correct to 2 decimal digits. So basically that is how you work with your sine rule. So I hope you understand better how you use your sine rule. So I would like us now to move and do cosine rule. Now, cosine rule in triangle ABC. Cosine rule in triangle ABC. Cosine rule in triangle ABC. As you can see there, we're looking at cosine rule in triangle ABC. Once again, the same thing applies. A is opposite to angle A. Small letter b as a length is opposite to angle B. Small letter c is opposite to angle C. So I can't overemphasize that anymore. You should be understanding it by now that small letter a is the side opposite capital letter A angle as an angle. Small letter b is the side opposite angle denoted by capital letter B, and small letter c is the side opposite angle C. So you should be knowing that by now, right? So please take note of this, that the cosine rule now is considering 3 sides. When 3 sides are given, only 3 sides are given, and then you are not given any angle. Or when you are given 2 sides and an included angle. I'm going to come to that. But let me just explain it. Basically, in cosine rule, you just say the square of one side of a triangle is equal to the sum of the squares of the other 2 sides minus, this is very important, otherwise it would look like Pythagoras theorem, minus twice the product of the 2 sides that multiplies each other, and then you multiply it by cos of the included angle of those 2 sides that you are talking about. So I'm just trying to explain it in English, otherwise mathematically we write it like this one. It's either a squared is equal to b squared plus c squared, or is b squared is equal to a squared plus c squared, or is c squared is equal to a squared plus b squared. But that would just be Pythagoras theorem. So I'm going to go back and explain the first one. Is a squared is equal to b squared plus c squared minus 2 times these 2 sides that are already on the right hand side. Please make sure that you use the sides that are already on the right hand side. Is 2 times these sides. That means you no longer have squares now. So it's 2 times b and c. And then if your unknown or your subject of the formula was a, small letter a, then your angle is going to be capital letter A, because it will be the included angle of these two sides. The two sides that are given, it will be the included angle. As you can see, angle A is included by B and C. In other words, it is formed by these two sides. It is formed by this side, which is denoted by small letter a, and that side, which is denoted by small letter b. It is formed by those two sides. We say it is included. So it means now the moment you have b squared, it's going to be b squared is equal to a squared plus c squared minus, once you say a squared plus c squared, you know it's going to be minus 2 times a times c, and then cos of the capital letter of what was the subject of the formula. The subject of the formula was b squared. So opposite to b as a side is obviously capital letter B, right? And then the other one will be c squared is equal to a squared plus b squared minus, of course, 2 times a b, and then cos, the angle for cos will now be the capital letter of what was the subject of the formula. The subject of the formula was c, so though it was squared, but the unknown there is c, so it means now the angle will be c as a capital letter. Very important that you understand that one, Mfundi. All right, right. Then now maybe let me go back a bit and say, how then is it written? It is written in this format, or is there any other format it can be written? Yes, it is, where you will make now cos of an angle the subject of the formula, especially when you are calculating angles. So we say now it can also be written in terms of the angles as follows. So you can write as cos A is equal to b squared plus c squared minus a squared over 2bc, or cos b is equal to a squared plus c squared minus b squared over 2. Take note of this, that this one, if the angle is a, then it's going to be minus a squared. If the angle is b, it's going to be minus b squared. If the angle is c, it's going to be minus c squared. So you add the squares of this one minus the side opposite to the angle, that is the square of the side opposite to the angle, and then divided by 2 times what you were adding, the sides that were adding there on top. So that's basically how you can write it, right? Remember now that the first format, that is this format, is obviously given in the formula sheet. This format is given in the formula sheet, but this one will not be given in the formula sheet. So you just have to understand. An alternative way of calculating an angle is obviously to substitute first, and then you see that, oh, I've got an unknown, and then try and make that unknown the subject of the formula. That's basically how you do in mathematics. You can just use a formula, substitute in that formula, and then see what is it that I don't know or is an unknown, and then you are able now to say, okay, let me make that one the subject of the formula, that is the one that you don't know. So the cosine rule can be used when the following information about triangle is given. All right, if you are given 2 sides and an angle, then you can use cosine rule, but that angle must be included. It must be included. It must be an included angle, or if you are given 3 sides. So once you are given 2 sides, ask yourself, is the angle that is given included or not? If it is included, that is between the 2 given sides, or is the one which is formed by these 2 given sides, it's an included angle, so cosine rule is going to work there. Or when you are given 3 sides, right? So it's very important. So this one is just overemphasizing what I've indicated. So if you are given this side and that side, then you must be given this angle. Then you can use cosine rule. Or if you are given this side and that side and that side, so you can use cosine rule to find any angle. All right, very important. Okay, so let's do an example so that we can see how do we then apply this cosine rule, or how do we use it to solve triangles, right? Once again, the question is solve the following triangle. Solve the following triangle, right? So in this case, we can see that there is a triangle ABC. We are given this side and we are given this side. And the nice thing about it is that we are given the angle which is formed by the two given sides. So we call it the included angle. Therefore, it means that you are able now to use cosine rule nicely there. Obviously, you'll start with the side which is opposite to the given angle, which is the only side which is not given. So c squared is equal to a squared plus b squared minus 2ab. Then cos the angle will be the one opposite to that side, which is angle C. Then the next step is just to substitute now. C is the square root of, and then a is 5. That is, remember now that this is small letter a. Maybe I should write that small letter a, and that is small letter b. Because now small letter b because it's opposite to b, small letter a because small letter is opposite to a. Remember, small letter c because it's opposite to angle C. Then you substitute. So a will be 5 squared plus b will be 7 squared, and then it will be minus 2 times 5 times 7 cos 65 degrees. Then yours is just to press the calculator and you get the answer. Remember, you don't necessarily have to use this small letter a and b, as long as you know that it can be a b squared, right, is equal to ac squared plus bc squared minus 2ac times bc cos of the angle opposite to the side that you are looking for, which is angle C. So the formula, the way of writing the formula is not necessarily prescriptive, as long as, that is in terms of the notation, as long as you indicate or you show the person who will be marking your script or your teacher or whoever when you're writing the final exam, the examiner or the marker, you must just make sure that you demonstrate understanding of cosine rule. Right, so you've got now C as 6,7. So that side is 6,7 now, 6,7. Then now it means now you don't know these two angles. You don't know these two angles, and then you can find one of those angles still by using cosine rule, because now you will take it as if you know all the three sides. But because you know that angle, you could have used the sine rule as well. But because we are under cosine rule, I want us to use cosine rule so that we can practice it. So it will be cos of the angle that I'm looking for. I'm looking for this angle, angle A. So it will be cos A is equal to b squared plus c squared. That is the two sides that are forming this angle. So b squared plus c squared minus a squared over 2bc. Alternatively, you could have just said a squared is equal to b squared plus c squared minus 2bc cos A, and then after that you write it in that format. Then after that you substitute, and your unknown will be cos A, and make cos A the subject of the formula. But I'm deciding to use the second format there. Then the next step is just to substitute, which is going to be 7 squared, right? 7 squared plus 6,7 squared minus 5 squared over 2 times 7 squared times 6,7. Then the answer will be cos A, still cos A, is equal to 0,73. This is very important. Cos A is equal to 0,73. And then in your calculator, you press shift or second function cos of this. And then the answer you will get is 42.7. 42.7 degrees. Then from there, once you know that now this one is 42.7, 42.7 degrees, then yours will be to just use Euclidean geometry as I indicated earlier. You just say 180 degrees minus the two given angles, and then your answer will be 72.3 degrees. In so doing, you have solved the triangle, right? So it is very important to note that. Now, lastly, let's just look at the area rule now. Area rule in triangle ABC. Once again, the side that is a small letter must be opposite to the angle. So A is opposite to A. That is, the side A as a small letter is opposite to angle A, which is a capital letter. Side B is opposite to capital letter B as an angle. Side C is opposite to capital letter C as an angle. It's just a reminder, this one. Then in the area rule, it's very simple. It's just area of triangle ABC. You can write it in 3 ways depending which sides are given and which angle is given, right? So remember that in triangle ABC, it's going to be half, the normal triangle is half base times height most. So this one, I'm not going to be deriving this, because deriving sine rule, cosine rule, and area rule is not for examination purposes. During your own spare time, you can try and look at how to derive these ones, but I'm not going to be deriving it in this lesson. Right now, so it's half small letter b, small letter c, sine. You have used in triangle ABC, you have used B, you have used C. So now it means the angle must be A. It means these two sides, this angle is included by these two sides. This angle is included by these two sides. This angle is included by these two sides. That's what is very important. Make sure in your formula you use all the alphabets. So that means it's half small letter b, small letter c, sine capital letter A, right? And then half small letter a, capital small letter c, sine capital letter B. Half small letter a, small letter b, sine capital letter C. And we can use the area rule when we are given two sides of a triangle and the included angle. As I indicated, you are given this side, you are given this side, so you're using AC, AC, it means you're going to use this angle, angle B. If you are given that one and that one, it means you're going to use this one. If you are given that one and that one, it means you are going to use this one, which is included. That's basically how you use area rule. Now quickly, as an example, solve the question should have been determine the area of that, not necessarily solve the triangle this time. Determine the area of triangle ABC. Determine the area of triangle ABC. So you are given this side, you are given that side, you are given that angle. That should be a straightforward one. So capital letter A, small letter A. Capital letter C, small letter C. Capital letter B, small letter B. So it means because you are given this angle as A, it means your area will be half small letter b, small letter c, because you want to use capital letter A. You want to use A. So if you want to use A, therefore in ABC, you are left with B and C. That is why you do it like that one. And then it's going to be half times 7. So in our next lesson, we shall use these rules to solve problems in 2D and 3D. Remember, this is mathematics or technical mathematics. So we must practice and practice and practice, because practice makes perfect. Thank you very much. See you next time.